Hi friends, I'm Grishma and you're watching my channel G Tutorial. In today's class, we can learn about permutations and combinations. I think this topic is not directly given in the syllabus of RRB JE, but we can expect questions from permutation and combination. So I took this topic. If you like my video, please subscribe to my channel for getting more RRB JE related videos. Now let us get to our class. First, let us see what is meant by product rule. If a certain task can be performed in n1 different ways, and for each of these ways, a second task can be performed in n2 different ways, then the number of ways in which both the tasks can be performed is n1 into n2. If you are seeing an example, you will can understand it clearly. An example is, a man has 9 trousers and 12 shirts. In how many different ways can he select a trouser and a shirt? That is, there is n1 different ways. That is, there are 9 trousers. And the second task is there are 12 shirts. And it is asked in how many different ways he can select a trouser and a shirt. That is just n1 into n2. That is n1 into n2. 9 into 12. 12 nines are 108. In 108 ways he can select a trouser and a shirt from 9 trousers and 12 shirts. Next question. This is the next question. There are 10 railway stations between a place X and another place Y. Find the number of different tickets that must be printed so as to enable a passenger to travel from any place to any other place. It is given that there are 10 railway stations between a point X and Y. X and Y are 2 places. Let it be Agra and Delhi. Then there are 10 places in between this. 10 stations, 10 small stations between this. So, if there are 10 stations in between this, then total number of railway stations is 10 plus 1, 11 plus 1, 12. So, total number of stations is 12. Then it is given that, then we are asked to find the number of different tickets that can be generated. So, we have to find the number of different tickets that can be generated. Before that, from X to X, ticket is not possible. It is not possible to go from X to X. It is the same place. So, the possible other choices are, so tickets can be generated in 11 ways. 11 tickets can be generated from X to first station, X to second station, X to third station. Like that, 11 tickets can be generated. So, we are asked to find the number of possible ways of generating ticket. That is, from X to first station is possible, from first station to second station is possible, from second to third, from first to Y, like that, different possible cases can arise. So, the number of different tickets that can be generated is just n1 into n2. n1 is the total number of railway stations, and from the first station it is possible to generate 11 tickets. So, the other possible cases are given by 12 into 11. 1 2s are 2, 2 plus 1 3, 1 1s are 1, 132. That's the possible number of tickets that can be generated. Next question. This is the next question. Find the number of ways in which Mr. Agash can invite one or more of his 6 friends for a party. We are asked to find the number of ways in which Mr. Agash can invite either one or more of us. There are 6 friends totally. And in how many ways he can call his 6 friends for a party. So, the cases are, a friend can be invited or he cannot be invited. So, there are 2 possible cases of inviting a friend. Like that, he has 6 friends. So, the possible cases is 2 raised to 6. Each friend is dealt in 2 ways. Can be invited or cannot be invited. Like that, there are 6 possible cases. And there is also a case where no friend can be invited. So, 2 raised to 6 minus 1 gives the number of ways in which Mr. Agash can invite one or more of his friends for a party. So 2 raised to 6 is 64 minus 1. 63 gives the answer for this question. Now we can see what is meant by permutation. Each of the arrangement which can be made by taking some or all of a number of things is called permutation. It is an arrangement. It is a type of arrangement, all arrangements that can be made by taking some or all of the given number of things. That is called permutation. In permutation, order of object is very important. Permutation just means arrangement, and here order is very much important. Now let us see an example. There are three things A, B and C, and we are taking two at a time. Then the possible permutations are AB, BA. AB is different from BA. There are two things AB and AB in these two cases, but the arrangement is different. The order of arrangement is different, so it is treated as two different things. So in permutation, order of arrangement is very important. So the two possible combination, two taken at a time, then the possible ways of arranging is AB, BA, BC, CB, CA, AC. So 6 possible ways of arrangement is present. Now we can see the general formula for permutation. Number of permutations of n things taken R at a time is given by NPR. N is the total number of things and we are taking R things from that. So it is given by n factorial by n minus R factorial. N factorial means n into n minus 1 into n minus 2 etc. into 1. If you are taking 3 factorial is 3 into 2 into 1. So NPR is n factorial by n minus R factorial. Now we can do some problems from permutations. This is the first question. How many 3-letter words are formed using the letters of the word rose? Rose is a 4-letter word. We have to form 3-letter words using this 4-letter words. How many, and we are asked to find how many 3-letter words can be formed using this word. So the answer is from the 4 letters we are choosing 3 letters. So 4P3 gives the number of 3-letter words that can be formed using the letters of the word rose. For total is written here, and how many letters are used to form the word, that is written over here. So 4P3, NPR is n factorial divided by n minus R factorial. 4 minus 3 is 1 factorial. So 4 factorial is 4 into 3 into 2 into 1 by 1. 4 minus 3 is 1. 1 factorial is 1. So 4 3s are 12, 12 2s are 24. 24 words can be, 3-letter words can be formed from the word rose. Next is, how many different words can be formed using all letters of the word September? We are using all letters. So how many different words can be formed using all letters? So we have to find the value of n and R. 1, 2, 3, 4, 5, 6, 7, 8, 9. So value of n is 9, and we are asked to use all of these words, all letters of the word. So R is also 9. So the value is NPR, which is from 9 different letters. We are using 9 different letters to form the word. So 9 is 9 factorial, n factorial by n minus R factorial. So 9 factorial by 9 minus 9 is 0 factorial. 0 factorial is actually 1. 0 factorial is 1. So 9 factorial is the answer of this question. Next question. Third question. Using all letters of the word Nokia, how many words can be formed which begin with N and end with A? We have to use the word Nokia. Use the letters of the word Nokia so that the word begins with A and begins with N and ends in A. So the middle letters can be all other O, K and I, and can be arranged in any possible ways. So we have to find the number of words that can be formed in such a way. That is, there is only 3 places, 3 factorial way. In 3 factorial ways, O, K and I can be arranged to form a word beginning with N and E. So the answer is just 3 factorial. 3 factorial is 3 into 2. 6 ways. Or 6 words can be formed in such a way, beginning with N and ending in A. Next question. Number of arrangements that can be made using the word meadows so that vowels occupy even place. Here the vowels are A, E, I and U. A, E, I, O, U. E, A, O are the vowels here. So 1, 2, 3, 4, 5, 6, 7 places. So if vowels occupy even places, these are the 3 places where vowels can occur, and 1, 2, 3, 4. These are the places where consonants can appear. So the possible arrangement is the consonants can be arranged in 4 different ways. So 4 factorial ways the consonants can be. Consonants, those that are not vowels are called consonants. So consonants can be arranged in 4 factorial ways, and there are 3 vowels, and when they occupy even places, it is in 2nd position, 4th position and 6th position. They can be arranged in E, A, O. Can be arranged in 3 factorial. There are 3 letters, so 3 factorial ways of arrangement. So the answer is 4 factorial into 3 factorial. 4 factorial is 4 into 3 into 2. For this at all, 12 2s are 24. Into 3 factorial is 3 into 2 into 1. 3 2s are 6. 24 into 6 is 144. So 144 ways these letters can be arranged so that vowels occupy the even places. Next is using the letters of the word count. We have to form new words so that vowels occur together. Here the vowels are O and U. We have to form words where vowels are appearing together. That is, OU appears together and the rest of the letters are C, N and T. So, if you are taking OU always appears together. So, the possible way of arrangement is 1, 2, 3 and 4. So, 4 factorial into this vowels can be arranged in either OU or UO. Both are different, no? So, they can be arranged in 2 factorial ways. This gives the total ways of arrangement of the word count so that vowels occur together. So 4 factorial is 24 into 2 factorial is 2. So 24 into 2 is 48. Next question. Next question. Number of permutations of the letters of the word mesmerize. We have to arrange mesmerize in different ways using all letters. So in mesmerize, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters are there. So 9 factorial divided by. We have to divide this possible arrangement by the repeating numbers. Here M occurs how many times? 2 times. E occurs 3 times. Then S occurs 2 times. So for M, we have to divide by 2 factorial. For S, we have to divide by 2 factorial. And for E, 3 factorial. So, this is the number of ways in which the letters of the word mesmerize can be arranged. That is 9 factorial by 2 factorial occurs 2 times. 2 factorial is square into 3 factorial. This is the answer for this question. Next question. Number of ways of arranging letters material so that vowels come together. So, in material, the vowels are A, E and I. The rest letters are, consonants are M, T, R and L. So, the possible way, also this vowels are treated as 1 and there are 4 others. So, 1, 2, 3, 4 and 5 letters are present. We are considering this vowel as a unique one. So, the possible ways of arrangement is 5 factorial. And within the vowels, there are 4 vowels. So they are arranged in how many ways? 4 factorial ways. But there is a repetition of A. So 2 times A is repeated. So divided by 2. This gives the answer for this question. So 5 factorial is 5 into 4 into 3 into 2 into 1. That is, in 5 there is, we can write like this now. So 2 factorial and 2 factorial get cancelled. So 5 into 4 into 3 into 4 factorial. 4 factorial is 26. 4 3s are 12. 12 5s are 60. So 24 into 60 gives the answer. That is 24 into 6 is 144. 1440. This gives the number of ways in which the words of the material can be arranged so that vowels occur together. Next question. This is the next question. In how many ways 5 boys and 3 girls sit in a row such that all boys sit together? So 5 boys are sitting together and there are 3 girls. So we are asked to find in how many ways these 5 boys and 3 girls can sit so that boys always sit together. So the possible ways is boys is treated as a single unit. So 1, 2, 3, 4. 4 factorial into. And within this one unit, boys can be arranged in, there are 5 boys, so they can be arranged in 5 factorial. So this gives the answer of the question. 4 factorial is 4 into 5 into 4 into 3 into 2 into 1. That is 24. 24 into 5 is 120. This gives the answer for this question. 24 into 12 is 4 2s are 8. 4 2s are 8. 2 2s are 4. 4 plus 4. 8. 4 8 8 0. This gives the answer for this question. Next question. A question paper has 5 problems. Each problem is having 3 internal or initial choices. In how many ways can a candidate attempt one or more problems? There are 5 problems and for each of the problem there is 3 choices. 3 choices A, B and C. And one cannot attempt that question also. So the possible ways of attempting a question is either he can choose these 3 options or he cannot write or he will not write any answer. So there are 4 possible ways of dealing with a question. Like that there are 5 questions. So the possible way is 4 ways of handling a question and there are 5 questions. So 4 raised to 5 is the possible number of ways of attempting these 5 questions. And from this we can subtract 1 because he is not attempting any of the questions. That gives the 1. So 4 raised to 5 can be 4 is 2 square. 2 raised to 2 the whole raised to 5 minus 1. Or we can write 2 raised to 2 into 5. 2 into 5 is 10. 2 raised to 10 is 1024. 1024 minus 1 is 1023. Now we have covered problems from permutations and also product rule. Most of the problems are from product rule. So it is important to study product rule along with permutation. In the next class we will be studying combinations. If you are having any doubt you can comment below. Thank you.